well, thanks, Paul. Thank you all for joining, and I am going to talk about DSPs in the buy side and working on a SaaS model. Really quickly, before I get going, there are 2 other 15 minutes with Beeswax webinars on similar topics, and they're both given by our managing director in the UK, Katie Jones. So one is on premium and programmatic, and the other is on supply path optimization. We'll touch a little bit on both today, but if you'd like to learn more, go to our YouTube channel and check out her presentations as well. So quick agenda. First, we're going to kind of talk about the background, how we got here, look at some architecture of how most bidders are deployed, and then really talk about the economics of it, sort of how things work today, how they could change, and what that would enable to happen from a SaaS side. But let's get into it, because the real question is why do we buy self-serve in programmatic on a % of spend? And there are a few different reasons, but I would argue the biggest is this guy right here, or in general, ad agencies from kind of the middle of the century, early 20th century. And in general, agencies and services organizations are monetizing resources. They're monetizing people, right? So as an account gets bigger, you put more people on the account, you need to increase the take rate for the account, or the amount of spend that comes through, or leave that flat and make sure that you get enough money to justify having all those people. But what we'll see in a second is actually on the software as a service side, as we've moved into programmatic, charging on a cost per 1,000 impressions, CPM, or on a % of media doesn't actually necessarily equate to how much the client costs the platform to manage. So why don't we talk a little bit about resource consumption, and we'll do it in kind of a fun way using property, but at the end of the day, what we're really looking at is 2 different types of technical infrastructure, both the multi-tenant and single-tenant infrastructure. So if you're familiar with New York City, you might have heard the term co-op. And so New York has this kind of weird model of in between an apartment building and a condo building, there is something called a co-op. And I lived in a co-op for 5 years on the Upper West Side of Manhattan. And in a co-op, you buy into the co-op with rights to your apartment. And what's weird about that model is it means that everybody equally shares things like utilities, services within the building, and taxes. And in my co-op, it was done on a square footage model, which you might think at the outset makes sense, right? But if you think about it, all those things are not necessarily interrelated. For instance, my wife and I were in our apartment. We had a 2-bedroom. We often were working all week, right? And we would often order in, whereas the woman who lived next door to us was cooking every day. She was retired, and so she was using a lot more utilities than we were, not cooking and not being around a lot. Now, there was a couple at the end of the hall, and they spent 6 months in Florida, but they actually had a 3-bedroom apartment, and they had a view of the Hudson River. And so the value of their apartment was much higher, and yet they weren't using it, and still they're paying on a square footage. So you can see there are a lot of things that happen when you have kind of a single metric that you're looking at that don't necessarily align usage with the actual cost of the asset. And that actually happens quite a bit with multi-tenant infrastructures, which is the way I would say, almost every single DSP out there is built today. So why don't we jump into exactly how that is? Because the initial paradox of operating a DSP is that obviously you have service charges, right? You have to have people working there, and you have to invest in technology. But the actual operations of the organization and operating the DSP, the #1 cost is the combinatorials that come from all your different supply objects and demand objects. So what do I mean from that? So on the supply side, you have tons of different SSPs or exchanges, and they're all sending a bunch of auctions every second to some sort of front end that receives them. And then there's a whole bunch of users on the back end, right? So that might be the graph of the DSP or customer users, and all those users have all these different data points around them, right? Past purchase behavior, ads they've seen, et cetera, et cetera. But this platform has to index every single supply object with every single demand object. And when you index every impression against every user, against every data point, et cetera, that starts to get really, really expensive. And so most DSPs, they actually try to deal with this by throttling their inbound supply. And the way this works essentially is this front end here, you say on any given day, knowing the campaigns that I have going live, I obviously want all my campaigns to deliver in full, but I think I can deliver in full by only letting in, say, half the display impressions in the US, or 80% of global video, or maybe only 20% of mobile app, because there's so much of it, right? And if you're a customer who broadly has some goals in here, you might not be that affected by it. But if you're a specific customer who wants to reach a specific geo or a private marketplace or a programmatic guarantee or an audience or a retargeting pixel, et cetera, you are going to have your audience sampled, right? So this platform might turn up a lot of these numbers in December, but when things come back in January, they have to control costs on their end. And yet if you're trying to reach a very specific retargeting audience and you're running on display and you only see 50% of impressions, you're actually losing out on half the impressions that you might be able to buy. And again, they're betting that that won't make a difference from a delivery standpoint, but from a performance standpoint, you have less choice, right? The other way that platforms typically deal with this, they either become like channel specific or audience specific. So there's a lot of CTV companies out there. And one nice thing about CTV is there just isn't that many auctions out there. So there aren't that many supply objects. I think there's 165,000 per second as opposed to like 10 million plus overall. And so that helps them control costs, right? Same thing with geos or data companies. And that's totally fine. You know, they might be able to get 100% of what they need, but in general, we kind of know all the limitations with that. And the limit is generally, you know, you have bunch of different point solutions that are all doing specific things, and it's really difficult to kind of aggregate everything you want to do. And so the ideal scenario is this, that you can tailor supply for 100% of the reach that you need and actually ignore the rest. And so if you look at this, a single tenant infrastructure, if you're actually deployed in your own house and you can do renovations to your own house, you should be able to filter by things like your own known users or the geos that you want, or specific exchanges or ad size or specific domains, et cetera, et cetera. And that really is kind of the kernel of what a single tenant infrastructure allows and can actually align with the needs of the advertiser or the client versus you know, what the platform sees. And quick Easter egg here, if you all have noticed, all of these companies now on the left no longer exist. And it's funny because in the 10 years I've been in this industry, they've all been around. So 10 points to anybody who can name every single company that each of these has become. So on the buy side, from a SaaS standpoint, the tenant infrastructure isn't the only thing, right? And so I'm going to define a couple terms and then talk about how they apply here. The first thing I'm going to say, talk about is float. So if you're unfamiliar, float is essentially the amount of money that you've paid to your suppliers before your clients pay you. And the problem here is that with a typical DSP relationship, someone goes in, they run a campaign on the DSP, and then the DSP pays their SSP 30 days later. Now, if you're a customer, you might be able to pay in 30 days, but you might need 45 days or 60 days. Let's say you're a brick and mortar retailer and you've sent out a bunch of ads to get people in store, but it takes a while for people to go in store and for you to make that money back. So you can't pay your DSP right away, or ideally you wouldn't. And putting another wrench in there, let's say that there's an agency involved, right? So it might take 45, 60 days for the client to pay the agency, and then the agency has to turn around and pay the DSP. And so this DSP now has shelled out money for 30 days that they might not receive for 90 or 120 days. Now, at the end of the day, if the DSP has that much cash on hand, they can probably cover this float. But if they don't, they will have to essentially borrow against it. And every dollar you don't have or is out in your account receivables are a dollar that you don't have today. Not to mention, sometimes clients go bankrupt, right? If Brooks Brothers or J. Crew were running on a DSP recently, they're probably not going to pay their DSP the full amount that they spent, right? Because they're both Chapter 11 in the last couple months. So the solution here from a SaaS standpoint would be if the buyer can actually generate a direct relationship with an SSP, they can pay the SSP directly. And this removes ambiguity for DSPs, right? They know whatever money is going through the platform, they are now a SaaS layer and not essentially a bank, right? It improves efficiency, right? Because in this scenario, the client has to have finance people, the agency has to have finance people, the DSP has to have finance people. This kind of cuts out two people or two players. And then the final thing here is buyers get full transparency, right? I mean, on a per dollar basis, buyers knowing exactly what's going to every SSP, they can validate the pipes of their DSP and essentially their bids and their wins, right? The second piece here is supply path optimization. And again, I won't go fully in depth on this because this screenshot I actually took from one of Katie's webinars that she did, I think, last month. But if you're familiar with the term header bidding, it's essentially just the ability for a publisher to have multiple exchanges, field requests on site. And as you can see from this really messy, scary graphic, there's essentially 3 publishers, but for 3 individual impressions, they end up through a network of SSPs, they send 6 bid requests to the DSP. Now remember, DSPs, their biggest cost is indexing supply objects and demand objects. So this balloons their supply objects, and if you start filtering, you might now actually be filtering down impressions that are duplicates, right? And so some of this can be done on the DSP side, but now that the client actually has a direct relationship to the SSP, they could work with each individual SSP and run with publishers on each and actually A/B test saying, okay, for these publishers that I run on a lot, this SSP is more efficient than this SSP. And if I only go through one, then I won't have any worry of having 2 SSPs give me the same request and I might be bidding against each other, right? And so, you know, it's the oldest trick in the book, but A/B testing with transparency can drive a lot of efficiency in terms of how things work. And it helps the DSP cut down on QPS. So I just said QPS, and you're probably wondering, well, what's that? Queries per second are essentially the ways that we measure the amount of inbound auctions for a certain bidding instance. And so it's a really important piece of how SaaS pricing works, because if you think about it, if each client is hosted separately, now you only have to index whatever data the client has. Obviously, the client's not going to want to cut down on their own data. They want as much of it as possible. And that's true of a multi-tenant DSP too. But if you're in a single tenant and a client just has their own data, then they're looking to say, how many supply objects am I going to let in? And how do I actually filter that? So we can talk about the filtering in a second, but at the end of the day, when they're looking to run on a SaaS model, it's essentially 3 things. It's the processing of those impressions, however many they are. It's any other tech infrastructure, right? Data centers, file delivery, things like that. Ad serving, for instance, we don't really think a lot about ad serving, but if you're a DSP and you're running on a percent of media, you probably don't charge separately for ad serving. But if you are hosting the ads versus having a third-party ad tag, you're actually incurring an additional cost, right? Whereas every client is paying the same amount. But if you're a customer that has the third-party ad server, you should be getting a discount, right? Because the DSP doesn't have to do anything. They just host the tag, which is, you know, 1-by-1, and they're done. And the third thing, if needed, would be services. And the interesting thing about QPS, and I hope I'm not going to end here on a relatively confusing graphic, but one thing to think about with QPS is that it scales really nicely, right? So if you're a big advertiser and you run multiple places, you're going to find efficiencies as you need more impressions. And one example would be, let's say you have a banner retargeting campaign, and let's say that's 3,000 auctions per second, right? And then you have a video prospecting campaign, maybe to an Oracle segment, that's 8,000 queries per second. Those two are obviously going to be different amounts of QPS, right? That makes sense. One is banner, one is video, one's retargeting, one's prospecting. But let's say you have a cross-device blended campaign. Obviously, most of this might be net new, but you're going to have some overlap with both of these. And these slivers of overlap, you no longer need to listen to twice, right? Because the traffic's already being sent to your bidder. The second is true if you had a campaign that was geo-focused, right? Here you want to really, really turn on the microscope for that geo, but at the same time, there was already probably some sample of the geo among these users and these users. And so, you know, if I could kind of summarize here, it would be that a single tenant infrastructure should allow for these things, right? A unique supply footprint, improved reach and aligned cost, right? Because at the end of the day, a SaaS model will work if a client is going to process only relevant supply and only relevant users and adapt processing over time. So at Beeswax, we are a single tenant infrastructure, and this essentially is our approach. And when we mention QPS to clients, it can be somewhat confusing. But at the end of the day, it usually works out. And so I'd like to give one more plug for another 15 minutes with Beeswax, which is from Doug Beal from our customer success team. And 2 weeks ago, he went really in depth on this. So Paul, if that works for you, I'm gonna pause for questions.
Yeah, thank you. That was really helpful, and really digging deep on how the different pricing models, how they came about, and why single tenant infrastructure makes a lot of sense for those buyers who want to have their what they pay be consonant with the value that they receive, as opposed to paying extra just because they're using premium inventory. And so that's a really useful thing. So we do have a question here. That is, what if I don't know how much QPS I need? So we do get this question quite often, so I'm glad that somebody asked it.
Yeah, that's a good question. And I sort of touched on it a little bit at the end, because it can sometimes be a moving target. What I will say from our perspective is you're going to get a really good deal out of the SaaS model in one of three circumstances. One, where you have a very specific audience you want to reach. One, where you have a very specific geo you want to reach. Or one, where you have very specific supply constraints, right? Because in each instance, and supply constraints would be like private marketplace deals or domains, etc. Because in each instance, you are able to constrain whatever supply is coming into your unique instance of the bidder. Now, to address the question directly, in instances where that is pretty easy, when we have a very specific instance that we're trying to use for a client, like a specific geo or a specific domain list or a specific user base. In instances where it's a little bit more open-ended, we essentially do some math on our end, and we'll work with customers to do that. But we take the amount of spend you're looking to put through, we take your effective CPM estimated, and then we essentially multiply that by your win rate and bid rate, right? And so if you think about it, the number of auctions I need, then my win rate and bid rate, or I should say bid rate and win rate, and that'll tell me how much I can spend at the end of the day.
Great. Well, that's all we have for today. So I want to thank you, Xander, for walking us through this. As always, this will be available on our YouTube page shortly, and those who couldn't make it will receive an email to watch it, and those who made it will receive an email saying, here, if you want to watch it again, you can watch it. And let me just remind you again, on Tuesday, hope you join us for our walkthrough of our new features to our UI and coming soon APIs. And as always, please stay safe. We'll see you again next time, and have a great rest of your week.
Thank you.